All right, greetings mathematicians. Um, I got another video here for you guys for today's lesson. So last class we were covering fractions and decimals, specifically comparing them, right? Which fraction is bigger, which fraction is smaller, so on and so forth, okay? So we have one more skill to practice with fractions and decimals, and that's how to convert them, how to convert fractions into decimals. So our focus question here is, how do we use what we know about fractions to estimate and compare decimals? Okay, so there are a few different situations that you might run into. First one, and probably the easiest to work with, is read it. It might be ready to write already. So read the fraction out loud, change it into a decimal. So I read this first one here as 3/10. So hopefully you remember that the decimal looks like this, 0.3, and the reason why that's the same is because there's a 3 in the tenths place. So I read this decimal as 3/10. All right, let's try the next one. 27 hundredths. Okay, so if you remember that, this isn't the answer here, but this right here is the hundredths place. Okay, and we want the last number there to be in the hundredths place. So I'm going to rewrite here, and therefore my decimal is 27 hundredths. Okay, and there we go. Next one. Ooh, I have a mixed number here. This is nice. Now, when we convert mixed numbers, the whole number is always going to go, I'm just using placeholders here, zeros. The whole number, this right here, is going to go right there in front of the decimal. Okay, always with mixed numbers. Okay, so I read this. Actually, hold the phone. I forgot something. Okay. Now, when you're converting into decimals, I really think it's important that you write the name. So I read this fraction as 3/10. Super important. That way you know that a 3 should go in the tenths place. This one here is 27 hundredths. Okay, and then this last one here is 1 and 12 hundredths. Okay, it's important to know the names because if you can say the names, you can definitely write the fraction or the decimal. Okay, so as I was saying, in mixed numbers, the whole number here is just going to go in front of the decimal. So I have a 1, my decimal, and then how do I write 12 hundredths? Remember, I'm using place values here, or just placeholders, excuse me. I'm using placeholders. Now, the last number here needs to go into the hundredths place. So I'm going to go ahead and change my numbers. And now I have 1 and 12 hundredths. There we go. So that's probably the easiest situation. You read it, and then you write it. Okay, next. Simplify it. It might be a friendly decimal you already know. Well, let's go ahead and simplify a little bit. So here I have 4/8. And when I divide the numerator and the denominator by 4, I get 1/2. And 1/2 written as a decimal is 5/10. Okay, and I want to show you guys that 1/2 is equal to 5/10, right? If you multiply the numerator and the denominator by 5, we get the same thing. So this is the decimal we write for 1/2. Or 5/10. All right, let's simplify 15/20ths. I'm going to switch colors here. I need a number that goes into both of these, and I believe it's 5. So I'm going to divide both the numerator and the denominator by 5, so I get 3 over 4, or 3/4. Okay, now you guys might remember that 1/4 written as a decimal is 25/100ths, written 0.25. I like to think of fourths as like quarters of a dollar, right? 1/4 is 25 cents, 2/4 is 50 cents, therefore 3/4 or 3/4 is the same as 75/100ths, written 0.75. And there we go. All right, let's keep going. 9/30ths. So again, you guys, this strategy is all about simplifying it. Simplifying it to a fraction that we know and we're comfortable with, and it translates easy into a decimal that we also know, okay? So I know that, well, let's see, what's the number that goes into 9 and 30? Let's try 3. And when I do this, this becomes a 3, and that becomes a 10. Well, we simplified it. Sorry for the long pause there. We simplified it. Read this fraction, please. 3/10. Oh, hey, look how this problem just turned into one of these original or first situation read it problems. So we can read it 3/10, and so we can easily write the decimal version written 0.3 but read as 3/10. There we go. Okay, let's keep going. A mixed number here. With the mixed number, you can leave the whole number alone, right? That's going to go in front of our decimal here. So I'm just going to leave it like that. Now I'm going to simplify this fraction here. I'm going to simplify 4/12. So I believe 4 goes into both of those. So let's divide. And 4 divided by 4 is 1. 12 divided by 4 is 3. Now, 1/3 as a decimal is, it's a little strange. If you guys have a calculator handy, I want you to type in 1 divided by 3 and then see what you get. You'll notice that when you do 1 divided by 3, you get this. 0.33333333333. Does it stop, Mr. RG? No, it does not. It keeps going on, but I'm going to run out of space. Your calculator, your screen runs out of space. So what we're going to write up here is I'm going to write, it's written as 5.3, but to tell the readers or the people who are going to read our test here, we know that this 3 keeps repeating over and over and over and over. So in order to mark that, so that way we don't have to write all of those 3's, I'm just going to put a line above this 3. That tells my reader that, hey, this 3 repeats over and over and over forever. Right? It's a little bit easier to write it that way. Okay, so our decimal becomes 5 and a repeating 3. 5.3 repeating. Okay, all right. The last situation, when you can't read the decimal, or you can't read the fraction, you cannot simplify it, well, we have this thing called the Kabbala Method. When the above methods fail, do what the fraction tells you to do and divide. Okay, so remember that fractions are just division problems. That's all they are, okay? So all y'all got to remember is that the top number is the cowboy and the bottom number is the horse. Okay? So when the cowboy returns home, right? This is his house. The cowboy goes inside the house and the horse stays outside. Okay, my southern accent is starting to fail me. Okay? So, here we go. We have a division problem. I'm going to erase this. There we go. I know that 6 does not go into 5. So immediately, I'm going to go ahead and put a decimal and a 0. Okay? Now, when you put a decimal inside the house, it's going to float straight up. Okay? Now, I know that 6 goes into 5 0 times, so I'm going to put a 0 here. And we're going to do our long division process. 0 times 6 is 0. I subtract. And then I bring down the next number. Now, I know 6 goes into 50. Well, how many times? Let's see. 6 times 4 is 24. Nope, way too small. 6 times 10 is 60. Nope, too big. 6 times 9 is 54. Getting closer. 6 times 8. There we go. That's 48. Okay, so I subtract, and I gotta move up here, sorry guys. There's 20. What am I talking about? I don't know what I'm doing. Yes, I do. Okay, 5 minus 4 is 1, and 0 minus 8. Oh my goodness, what am I doing? I need to borrow. There we go. Now I know what I'm doing. Sorry guys. It's getting late. So 10 minus 8 leaves us 2. Actually, what I'm going to do here is I'm going to move this up so that way I have a little bit more room. Hopefully you guys have enough room. Actually, this is what I'm going to do. Line it up like that so I end up writing my answer where it needs to be. Okay, there we go. Now, that's a 2, and I keep going. I add another 0. I bring the 0 all the way down. 6 goes into 23 times, because 3 times 6 is 18. And I subtract. I need to borrow again. That becomes a 1. That becomes a 10. That becomes a 2. Uh-oh. What's happening? 6 goes into 23 times. I think I might get one of these pesky repeating decimals, just like we got, just like we did over here. Okay, so what I'm going to do is instead of just writing 3's over and over and over, I'm going to put that little bar above the 3, because the 3 is repeating over and over and over. Okay, man, these are tough fractions here. Okay, let's do it again. So remember that the cowboy is on top. He goes inside the house. And then the horse stays outside. I know immediately 9 does not go into 4, so I'm going to go ahead and put a decimal in there. Once you put a decimal inside the house, it's going to go straight up. Now, 9 goes into 4 0 times. 0 times 9 is 0. I subtract, and then I bring down that 0. Now 9 goes into 40. I know 4 times 9 is 36. That's actually, yeah, that's perfect. Now 4 times 9 is 36, just like we said. And then let's subtract. I need to borrow here. That's a 4. 9 doesn't go into 4, so I'm going to add a 0 there. Bring it all the way down. It's another 4. 4 goes in. 4 times 9 is 36. Uh-oh. It looks like we have another one of those repeating decimals. We're just going to get 4's over and over and over and over and over. So why don't we just stop there? So what we're going to do is we're just going to put a bar above the 4s, because the 4s repeat over and over. All right, last one. Even what are these fractions? Okay, so cowboy goes inside the house, horse stays outside. 11 definitely doesn't go into 3, so I'm going to immediately put my decimal and make it float to the top. So that's a 0. 0 times 11 is 0. I subtract, and then I bring down this 0. 11 goes into 30 2 times. 2 times 11 is 22. I subtract. I need to borrow here. That becomes an 8, right? 10 minus 2 is 8. 2 minus 2 is 0. I need to add another 0 because I need to keep dividing here. 11 goes into 80 7 times. 7 times 11 is 77. I subtract. 80 minus 77 is 3. I'm going to add another 0, bring it all the way down. 11 goes into 30 2 times. Uh-oh. We might be repeating decimal here. Well, let's double check, okay? 2 times 11 is 22. 30 minus 22 is 8. I add another 0, bring it all the way down. Yep, I think we got a repeating decimal. So what we're going to do is I'm going to erase this 2, because what happens is we get another 27, right? So this decimal actually repeats 0.272727272727 forever. So what I'm going to do is I'm just going to write 0.27 and put a bar over the 2 and the 7, because those two numbers repeat over and over and over. All right, so that's how we convert fractions into decimals. Got 3 different ways. You can read it, you can simplify it, and then of course you can always divide, just like fractions tell you to do. Okay, now we're going to compare decimals using fraction benchmarks and decimal place values. And we're going to insert a less than sign, greater than sign, or equal to symbol. Now, I don't know about you, but the way that I like to compare decimals is I like to write them on top of each other. So 0.8, 0.2. And I want to make sure that my decimals are lined up, because then I can compare the place values. Well, is 8 larger than 2? Yes, it is. So your alligator has to go ahead and eat the larger meal here. Okay, let's do it again for not 0.4, 4 tenths. 4 tenths and 44 hundredths. Let's go ahead and stack them on top of each other. So I have 44 hundredths and 4 tenths. Now, because 44 hundredths has another decimal place, I'm gonna in 4 tenths I'm gonna add a 0 here. Okay, as a placeholder. So looking at the tenths place, they're the same value. So that's not really going to help me determine which one's bigger. So I'm going to keep moving along my place values here. I'm going to look at the hundredths place. Well, is 4 bigger than 0? Yes, it is. So I should say that 44 hundredths is greater than 4 tenths. All right, let's keep going. Ooh, negative decimals. So again, I'm going to line these up. Make sure my decimals are lined up. Okay, now let's just pretend that these are positive. Looking at the tenths place, you can already see that 3 tenths is bigger than 27 hundredths, right? Because 3 is bigger than 2, okay? But just like we said in class, when things become negative, everything kind of flips backwards, right? So I know that 3 tenths is bigger than 27 hundredths in positive land, but in negative land, it's actually the opposite. So we say that 27 hundredths is greater than 3 tenths, or negative 3 tenths. Excuse me, negative 27 hundredths is greater than negative 3 tenths, okay? And there we go. All right, last one. Let's go ahead and let's line them up. So I have negative 1 and 25 thousandths. And then I have negative 1 and 25 hundredths. So starting with the tenths place. Actually, excuse me, starting with the ones place, that's where we should start. Well, it's not really going to help us actually because they're both negative 1. So let's keep moving on. The tenths place. Again, if these were positive, let's imagine they're positive for right now. 1 and 25 thousandths would be less than 1 and 25 hundredths. Because 2 is definitely greater than 0, don't you agree? Yes. So if these are positive, we would write our little alligator mouth going this way. But because we're in negative land, because these are negatives, it's backwards. So we are going to say that negative 1 and 25 thousandths is greater than negative 1 and 25 hundredths. All right. Well, there you have it. There's the first part of our lesson. I hope you guys enjoyed it. See you in the next one.